Alright, let's go through this whole 2018 problem here. Even though we did most of part A, I'm still going to go through part A. So in this, we're setting up an integral, right? We're given f of 1, we want to find f of negative 5. So that means I'm going to set this up as the integral from negative 5 to 1 of g of x dx, and that's going to equal f of 1 minus f of negative 5. So we said this area from negative 1 or negative 5 to 1, we're just looking at this area under the curve. So this we're going to find all geometrically. So first, this trapezoid here, it's got a base of 4, base of 3, and a height of 3, so base plus base is 7, divided by 2 is 7 halves, times a height of 3 is 21 halves, and it's negative since it's below the x-axis, so this would be negative 21 halves. There would be no area here between negative 1 and 0, and then in between 0 and 1, the area of this triangle would be 1 half times 1 times 2, which would just be 1. So negative 21 halves plus 1 equals, now I know that f of 1 is equal to 3, so I can replace that with 3, then minus f of negative 5. So now I just have to solve this for f of negative 5. So I can subtract this 3 over. So negative 21 halves, 1 minus 3 gets me negative 2. That equals negative f of negative 5. Now, I would just need to, I can combine these easily, right? This would be minus 4 halves, so this would be negative 25 over 2 equals negative f of negative 5. Then multiply both sides by negative 1, and we just get 25 over 2 equals f of negative 5. Now, I mentioned in class, right, we don't even have to do that simplification. Right? I could just leave this as negative 21 over 2 minus 2, and then multiply both of those by negative 1. I could just leave this as 21 over 2 plus 2. Right? I don't even have to simplify that. That would be a 100% correct final answer for part A. All right, part B then says evaluate the integral from 1 to 6. So I'm looking at this area, right? I'm starting here at 1. I'm going to have to split this up then, right? I'm going to have to look at the area from 1 to 3, right? That's where that new curve starts, right? It says that this g of x, this quadratic, starts at x equals 3. So first, I need to take into account this square, and then I need to take into account the area under this quadratic from, that's not even close, from 3 to 6, right? So I need to split up my integral. So first, I'll say I want the area from 1 to 3, and that function right there is just y equals 2. So I can say from 1 to 3 of 2 dx plus the area from 3 to 6 of this quadratic, which I know is 2 times x minus 4 squared dx. Now, this was on the non-calculator portion, so we would have to evaluate this by hand. Right? This one is really easy. Right? We can just look at the graph and see that that has an area of 2 times 2, which is 4. So 4 plus, now I need to evaluate this. Well, we'll need to multiply this out. So I'm going to say this is the integral from 3 to 6 of, well, x minus 4 squared would be x squared. I'm going to do this all in one step. So it'd be x squared minus 2 times the product of the two. So 2x squared minus 16x plus 32. Okay, I did that all in one step. I multiplied out this x minus 4, and then I multiplied that by 2. Now we need to integrate this. So still going to have this 4, then plus I need the antiderivative of all of this. So this would be 2/3 x cubed minus 8x squared plus 32x, and I want to evaluate that from 3 to 6. So 4 plus 2/3 times 6 cubed minus 8 times 6 squared plus 32 times 6 minus 2/3 times 3 cubed minus, it's a cube, minus 8 times 3 squared plus 32 times 3. Now, we don't have to go any further than this. Once we have everything in terms of numbers, that is my answer. I do not have to simplify past this. I don't have to figure out what 6 to the third is by hand and multiply that by 2/3. This can be my final answer. Okay? This is a 100% correct answer. Do not have to go further than this. All right? So, if we did actually simplify all of this, though, we would just get 10, which ends up being a pretty nice answer. But we can leave it just like this. All right? Part C, then, says, on this interval, -5 to 6, on what open intervals is the graph of f both increasing and concave up? So this is g. G is the derivative of f. So I want to figure out where f is both increasing and concave up. Well, f will be increasing wherever its derivative is positive. Okay, so first, I want to say, well, f is increasing on the intervals 0 to 4 and 4 to 6. Right? So 0 to 4 and 4 to 6. And that is because its derivative, g, is positive. Then we would say that f is concave up. Okay, f is going to be concave up wherever its derivative is, excuse me, wherever its derivative has a positive slope. So that's going to be here from -2 to 1, from 0 to 1, and then 4 to 6. So -2 to -1, 0 to 1, and 4 to 6. So what this question is asking is, where do both of these things occur simultaneously? So they would occur simultaneously from 0 to 1 and 4 to 6. So we can say f is both increasing and concave up on the intervals 0 to 1 and 4 to 6, and then we have to give a reason, we have to justify. So we can say because g, which is the derivative of f, is both positive and increasing on these intervals. All right, so half of the points from this come from the correct answer, and then half come from the justification. The part D then says find the x-coordinate of each point of inflection. So remember, this graph is just the derivative of f. So we want points of inflection of my original function. Points of inflection of my original function will come wherever the slope of the derivative changes sign. Okay, wherever we have a local min or a max. Well, that actually only occurs here, because from here to here, we're going from 0 to a positive slope, then positive to 0, then 0 to positive, to 0, then 0 to a negative slope. So the only place where the slope changes from either positive to negative or negative to positive is here at x equals 4. Okay, so that's what we would want to write out. So at x equals 4, because g of x, which is the derivative of f, changes from, we could say, negative slope to positive slope, or from decreasing to increasing. All right. So lastly, I just wanted to look at the scoring rubric for this question. All right. So here's how the points were divided up. 2 points for part 1, 1 point just for writing the correct integral, right? And that, so just this first line, right, that was worth a point. The integral from -5 to 1 of my function is equal to f of 1 minus f of -5. And then the second point came from getting the correct answer. Then part B, we get a point just for that initial splitting up of the integral. Then a second point for the correct antiderivative. Okay, we did it a different way than they did. Okay, we'll learn how to do it this way shortly. And then another point for getting the correct answer. Okay, and again, our correct answer, okay, this was our correct answer. We did not have to simplify this. This is worth the answer point. All right. And then for part C, again, 2 points, 1 for the correct intervals from 0 to 1 and 4 to 6, and then for the reason. Okay, we said that the g of x is positive and it's increasing. And then part D, again, D was 2 points, saying the graph of f has a point of inflection at x equals 4, and f prime changes from decreasing to increasing at x equals 4. All right, so try that extra sample problem that I gave you in class, and we will talk about that one tomorrow. Email me or send me any questions through Remind.